Basically, there are two main options for recycling of metals. The idea behind the first one is to create new processes to recover elements from scrap and waste materials. However, this takes time because new R&D work is needed. It may also be expensive because a lot of new infrastructure must be built. The second option is to utilize existing base metals metallurgical infrastructure. It is a low-cost option because technology and infrastructure exist. However, wise sorting systems are needed, otherwise a lot of elements will be lost. New side product technologies may also be needed. So, what are the base metals? This is important to know because existing metallurgical infrastructure is optimized for base metal production. The weave is quite different according to market size and metal production, as can be seen from these diagrams. Traditionally, a base metal means a common and inexpensive metal. It has its own production plants and processes, like iron and steel, aluminium, copper and nickel, zinc and lead, magnesium and lithium, tin. Usually, the huge production infrastructure of the base metals also contains refining processes to recover the other elements as co-products. In this metal wheel, the base metal processes are shown as slices, which visualize process ability to recover other metals as co-products. Basically, the existing metallurgical plants for base metals are able to recirculate the majority of valuable metals. These plants also have side processes to recover valuable minor elements from scrap and waste materials. In fact, existing metallurgical plants are the key enablers of circular economy. These plants may be used to minimize waste accumulation by turning almost all waste materials into products. However, wise sorting systems must be developed, otherwise a lot of elements will be lost. For example, copper and nickel base metal processes usually also recover a large number of other metals as side products. Of course, copper and nickel are the main products, but a lot of valuable elements are also recovered, like gold, silver, cobalt, zinc, lead, and so on. These are illustrated in green in this diagram. The orange compounds in alloys, slags, flue dust can partially be recovered and utilized. The red ones are lost due to the dilution in complex mixtures and so on, making it uneconomic to recover them. The second example concerns zinc and lead base metals. Zinc and lead plants are usually linked to an existing chemical plant which recovers the valuable minor elements like gallium, indium, tin, gold, silver, and so on. For example, cadmium and tellurium in solar cell scrap can be recycled using existing zinc and lead plants. The indium in LCD screen scrap can also be utilized and refined in zinc and lead plant processes. The key message is that not only are some elements critical for our society, but the available base metal processes infrastructure is also critical. This simply means that we need copper, zinc, lead, and so on plants in the European Union area.